This is a pre-built version of the application, so we can pick up data from one of three places, either from files or from the database or from hard-coded. And if we were to pick it up from file, we can put the file under this directory, and we can add or remove files here. And each file will contain a grouping of cities and the name and latitude and longitude coordinates for each city. And here we create tables for grouping of cities, and we populate those tables. So city name, longitude, and latitude coordinates. And we can add or remove cities here. Or groupings of cities. So let's go ahead and create the database. And for hard-coded data, we have them in this class. So we have groupings of cities, and we can add or remove groupings here. And if we do that, we have to add it here. Add the listing or remove a listing from here. So let's go ahead and run the application and go for data coming from file. So we have those options, and we go for Chinese cities. So we have those 7 cities here with their longitude and latitude coordinates. So let's try to solve the traveling salesman problem using brute force. And we have 7 cities, so we end up with 7 factorial permutations, and all of those are equivalent. And we can use a genetic algorithm, and we end up with this number. So slightly higher. Can do hill climbing. And if we are to pick data from the database, we have those options in the database. So we'll pick up US cities, and we have those 8 cities with their longitude and latitude coordinates. So if we do brute force, we end up with 8 factorial permutations. And all of those are equivalent. And we can do simulated annealing. End up with this number and nearest neighbors. And for hard-coded data, we currently have those options. So let's see, or let's go for Japanese cities. We have those, and we can do maybe nearest neighbors, and we end up with this total distance. Next, let's quickly go over the code. So this class represents a city identified by its longitude and latitude coordinates, and the Haver-Sign formula is used for calculating distances between two cities. And this class contains hard-coded groups of cities with their latitude and longitude coordinates, and we can add or remove lists of cities as needed here. And this class represents a route, and each route starts from one of the cities, visits each city once, and then returns to the originating city, and it contains logic to calculate and return the total route distance. And this GA route is a route class used with genetic algorithms. And this class has cities data where they can be picked up from file SQLite database or from hard-coded, and it prompts the user for either table name, file name, or hard-coded data name. And extending classes implement the run algorithm, this abstract method. So they implement the run algorithm method where a specific functionality is triggered. For example, hill climbing or genetic algorithm functionality. So we have brute force handler extends the abstract handler, and it triggers brute force functionality. And GA handler extends also abstract handler, and it triggers genetic algorithm functionality. And this hill climbing handler also extends it, and it triggers hill climbing functionality. And this one triggers simulated annealing functionality, and this one nearest neighbors functionality. And the algorithms, for example, the brute force algorithm systematically checks all possible candidate solutions until we find the correct one. And the genetic algorithm is inspired by biological evolution, and it iteratively processes a population of candidate solutions using a method modeled on natural selection, so crossover and mutation to solve and find the best possible solution. So this one is associated with the genetic algorithm, the population class, and it represents a population of genetic algorithm candidate solutions. And this class works by progressively decreasing the temperature from an initial positive value to a set minimal. And at each step, the algorithm randomly selects a solution close to the current one, measures its quality, and moves towards it according to the temperature-dependent probabilities of selecting better or worse solutions. And this class starts at an arbitrary city, repeatedly moves to the closest unvisited city, and finally returns to the starting city. And this one, so the hill climbing algorithm operates like climbing a foggy mountain. It constantly moves in the direction of the steepest immediate ascent until reaching a peak where no surrounding steps go higher. And this driver class drives the application framework drives the application, and the framework can use data coming from one of three places. So it prompts the user for file, table, or hard-coded data source, and it prompts him for a specific algorithm to find the shortest traveling salesman problem route between cities. And here each city is identified by its latitude and longitude coordinates. And the Haversine formula is used for calculating distances between two cities. And here we call the static method run framework on this class. Now the source code will be available for download. Also a members only version, including step-by-step coding, will be available for viewing by channel members at the senior software engineer level and above.